Okay, we ever take an interesting sum? We've got the sum from 1 to infinity of n over 3 to the n. Okay, I was definitely thinking this is very similar to the geometric series. If we just didn't have that n there, it would be the same thing. Take that n away and this would just be 1/3 of the n, and we could just use our geometric series formula and get to our answer really quick. But with that n there, we're going to need a different strategy, but we can still use our formula for the geometric series. What I'm going to do is, let's call that, we'll call the formula for the geometric series f of x, and our formula for that is just going to be the sum from n equals 0 to infinity of x to the n, and this is going to be the same thing as 1 over 1 minus x, but it only converges when the absolute value of x is going to be less than 1. And then from here, what I want to do is let's just differentiate this to get a value for f prime of x. So we'll just be using the power rule on this. So for our sum power rule here, it's just going to be n times x, n minus 1. But one thing to notice, when n is 0, that's going to wipe out the expression. So I can kind of just eliminate this first term, and we can write this lower bound as just n equal to 1. And then for this minus 1, I can actually break this off separately, right? And then we can do that, bring it into the denominator as 1 over x. But then 1 over x is not going to be dependent on n, so I can take this and bring it out front of the sum, and we can write it as 1 over x times everything else. Now, one other thing I can do, we differentiate the left side. Why don't I differentiate the right side of this equation? We can differentiate 1 over 1 minus x. Let's just put that right here. To calculate this derivative, we can just do it with power rule. I can write 1 over 1 minus x as 1 minus x to the minus 1. Then differentiate it with power rule, you get minus 1 minus x minus 2. Chain rule, a minus sign comes out. This changes this to a plus. Then just rewriting it, we can write this as 1 over 1 minus x all squared. So that's going to be our value for f prime of x. Now, one thing I can do, coming back to our original problem, I want to make this look a little more, I'm trying to equate it to what we have right here. Well, let's just rearrange this a little bit. I can actually bring this, write it like this, n in front. For 1 over 3 to the n, I can write this as 1/3 to the n. And now we have it set up like this, where it's kind of like this is our x value right here. So then what we can do is use this. Let's just look at what happens if we have f prime of 1/3. Plug 1/3 in here, that's going to become a 3 in front. Then we have our sum. This is going to become n times 1/3 to the n. But then we can also do the same thing with this other equation for our f prime of 1/3. Plugging in here, this is going to be 1 over 1 minus 1/3. That's going to be 2/3. And this is all going to be squared. Squaring that out, we're going to have 4/9 in the denominator, flip it, and this value is going to be just 9 over 4. So what we can do is just set these two things equal. This thing is going to be the same thing as 9 over 4. And so then all I need to do is, if I can just solve for this piece right here, that's going to be the answer to our problem. So doing this, I'll just divide by 3 here, multiply by 1/3 here. But then I can cancel 3 with 9 here, and we get a 3. And so for my final solution for this, we just get 3 over 4. Okay, there you have it. Interesting series problem, sum of n over 3 to the n. Thanks everyone for watching. Have a good day.